Welcome, everyone. Morning. I know people in Bristol had a difficult start this morning after the conference party last night, and I appreciate the early risers that managed to make it 2 sessions today early in the morning. And today we're going to talk about some C++ myths. And I'm hoping this session will stir up discussion around various topics, and I even encourage people to come up with new things or new myths they've heard floating around. Do ask questions as we go along. Comments are welcomed too. So I'll try to keep an eye on the Q&A tab in Zoom for those participating online. People in the room can go up to the mic and ask questions. My understanding is that this can be arranged. So feel free to interrupt, ask questions, post comments, anything. And of course, if discussions tend to go long, or maybe there are too many topics to cover live, I do encourage people to go on Discord in the appropriate channel, and we can continue discussion there for as long as needed. So depending on your preferred medium of interaction, don't feel intimidated to instigate a friendly dialogue on these topics or any other. And I'll start by acknowledging that the C++ community is very large and sometimes quite vocal when it comes to controversial issues. People like to argue, and I'm not talking about code reviews. Sometimes things can easily get out of control, even in public forums such as Twitter or Discord, Slack. So it stems from the fact that we're actually different, and our C++ community is very fragmented on many topics. This is based on the breadth of the C++ ecosystem on one part, and the background and experience we each bring from our particular C++ niche that we're living in. So we sometimes tend to don't favor opinions that come from other parts of the industry. So when people say they program C++ for a living, it's a fairly vague term, because it highly depends on the kind of products that they're working on, the restrictions, their industry, the regulations, or the performance limitations of their components. So they come with this baggage and sometimes with prejudice when it comes to various controversial topics. So we need to be understanding, and we need to analyze each idea depending on the context in which it matters, because some things might be a good idea in one context, but not a very great strategy in other environments. So I think of it as parts. Björn Sturstrup likes to use the elephant metaphor in terms of people's understanding of the C++ language and its various uses. I like to think of it as various tasty parts. I apologize for the non-meat loving people in the audience, but that's how I see it. And in terms of sources, there's a lot of good information easily available these days. It's not like 20 years ago when I started. I know I'm starting to sound like an old man. But nowadays, you can easily reference CppCoreGuidelines, for better or worse. There are lots of best practice books and blogs and articles, some of them highly opinionated. There are established idioms, and sometimes we need to be skeptical of those and their frame and their timeline. There's lots of good books. There's lots of outdated books. There are very nice conference presentations. Many of them I'm going to reference in this talk today. And of course, the inevitable Stack Overflow, where things really get settled. And word of caution on hot take typing. If it looks like a hot take and if it feels like a hot take, it probably is. So don't try to take it too literally. I know many people like to joke around, and some of them have tremendous weight and respect in the community. And sometimes they're maybe misunderstood. So you have to judge each tip on its merits there. So a word of caution. And mixed up with all of this, there are plenty of myths. And that's the subject of today's discussion. Some myths stem from obsolete information, blogs, books, even presentations, and some from very bad teaching materials. And yes, there are lots of them around. And many of them were bad at the time of the publishing. So it's not an issue of notwithstanding the test of time or evolution of C++. So viewer caution advised. And if we're talking about teaching, because this is a very important subject for me, I'm not trying to frame these myths or idioms just in the context of a lively discussion or a thread during code review between peers at work. In the back of my head, there's always the subject of teaching, because I've done that a lot. And I do care about this. So some of the items might seem silly or obvious to some folks, but I've heard them time and time again, and I had to discuss them with junior developers or interns we hired fresh out of college. And I've gotten some questions repeatedly during my lectures at my alma mater. So let's not forget that C++ myths and idioms are not just for the experienced programmers or for people that have been entrenched in this business for more than 10 years. C++ and its gotchas need to be properly dealt with and understood by people approaching the language for the first time, approaching the libraries, and starting to program for a living. So always try to keep in mind that these myths and idioms that we like to surround ourselves with do affect the newcomers to our community. And we have to be very open-minded and accommodating to these folks, because let's not forget that we were there too. On the subject of teaching C++ and my experience dealing with uni and college students, I did a short presentation last year at the ACCU, my C++ universe. If you're interested in such topics, I reference this here. By the way, throughout my presentation, when I reference external materials, I do post links. So when the slides are published, feel free to study further on your own. Follow the links and your curiosity. And on the subject of people trying to learn, people trying to figure out this territory and starting to program for a living and starting to approaching C++, maybe as a first language, who knows. I think for most people getting into our community, sometimes the experience might be discouraging. So I urge all of you to try to be very careful when imparting wisdom or experience or when solving issues, and try to be considerate to those asking questions, because there are no silly questions, really. It's just a matter of where you are in your learning path. So let's not forget that. There are lots of good content out there, lots of great Stack Overflow questions with lots of details, and some people are really good explainers. But we must never forget that we have to be patient, and we have a responsibility in educating the generation that follows us. And this is kind of the background from where I started thinking about these issues and frustrations with various things floating around. And I told Jason that we should do an improv session. So we did that more than a year ago. We did a live stream over 2 hours. And we basically started with no real plan, just a list of issues that I wanted to go through. And of course, we didn't manage to cover not even 10% of what I had planned. But I wanted it deliberately to be an improvisation session where we get to chat about these topics and try out things. So we definitely didn't prepare anything, and we wanted to the outcomes and conclusions to come out naturally. And we had a very good chat interaction while the event was live, and people contributed and asked questions, and we basically adjusted our plans as we went along. So it was an interesting experience, but I'm guessing that most people won't have the patience to follow a 2-hour stream. So in investigating these kinds of topics, I wanted to frame this as a familiar verdict-like scenario. Of course, it's somewhat forced metaphor, because it's not always clear-cut. So I do want to instigate a healthy dialogue, so do speak up. Again, I remind you that you're free to use the Q&A tab or ask questions live, even comment if you don't agree or anything. So as long as the dialogue is civilized, I'm more than happy to be challenged on the things I say. So we have the usual confirmed and busted myths, and programmers' favorite response, it depends, which would be the plausible case for a myth. So some things, of course, will fall into this category. As I alluded earlier, it very much depends on the context in which we analyze each idea. So let's test this and see if we're all on the same wavelength. IO streams are slow. Yeah, just kidding. This is not really a myth. We've known this for years. So this would be the confirmed case. What else? C++ modules will solve all our problems. Yeah, this is a busted myth. I think we agree by now that they will not solve all our problems. Coroutines shipped in C++20. Let's say this would be a plausible myth. Unfortunately, with no real library support in 20, it's not really a confirmed landing of coroutines in C++20, but we're going to get a generators library in 23. So there's hope. So that's why I put this one in the plausible category. Okay, so now that we practiced, I think we can go on with it, with the presentation. And I want to stress out that this would be, as I thought of it, as part 1 of N kind of presentations. And as a new thing, I would like to invite other speakers to join in this C++ myth busting series with their own presentations and tackle new stuff, or maybe challenge some of the stuff I present today. And I'm hoping to start to build a series of these kinds of presentations where people get comfortable discussing issues and challenged established idioms and try to dismantle some of the myths around some topics. I'm going to try to use Scott Meyer's indexing. In my day, when I learned C++, people were all about quoting item 14, item 23, item 41 from effective C++. In discussions, in code reviews, people would often throw in, I think this falls into the item 14 discussion, or maybe a Guru of the Week issue number. Older people will appreciate this. I know I still think in terms of some of these issues. Of course, many items on those lists are no longer applicable in modern C++ or no longer necessary. But as a novelty, I wanted to try out to use Scott Meyer's indexing for these myths. So I'm going to start right from the bat with myth 11. Yes, it's from a list I keep. Because we talked about IO streams earlier and how notoriously bad they are, I'm going to tackle this one first. And that is Printf and sprintf are very fast. And people usually mean comparatively to IO streams. It's not hard to beat that. But let's see. Sprintf actually uses the global locale, and not everyone is aware of that. It makes sense, but not everyone is aware of that. And as a consequence of that, it actually takes a mutex lock, which is unfortunate. And it can get really unpleasant on some operating systems. For example, on Mac OS, sprintf, which is part of the system libraries, ends up spending almost all of its time inside the locale-related mutex lock. So that's highly unfortunate. On Windows, the situation is a little better. I read a case study by Blender when they switched a particular component from sprintf to using lib format, and the benchmarks are impressive, to say the least. So mind you, they're not switching from IO streams to lib format, they're switching from printf, or in this case, sprintf. So on Mac OS, we're talking about 3 or 4 times speed up, so that's times. And on Windows, around 20% speed up, partly because of a faster floating formatter on Windows recently. So I think that's impressive. So I would say this myth is pretty much busted. And I do encourage people to use C++20 format if they can, if they're on 20, or use lib format otherwise. It's a fairly easy library to adopt. It doesn't have dependencies. It's fairly easy to integrate in the project and keep it up to date. So if you need format, print, do go for these kinds of things. So do go for lib format or standard format. On some implementations, standard format actually is implemented in terms of lib format. So we have a proven record here of a library that it's far superior in terms of performance and a better API, I would say. In general, I would say that people need to be aware of standard functions that use the locale. It's not always obvious. And unfortunately, we don't have a precompiled list of standard library functions that use locales. And more people should be aware of these when they're using it. So it's not always obvious. For example, think of chrono and formatting around chrono, stuff like that. Okay, next one. Myth 14. C++ is not easily toolable. I've heard that a lot. And yep, we tend to use tools a lot and depend on them. And we've been doing that for thousands of years. And I'm a tool builder, and I've always built tools for developers. From commercial tools that I did, and I've worked on commercial tools for developers for 17 years now, to open source projects. I posted here a link to lots of small little tools that I built over time. I built static analyzers, linters, formatters, what have you, even IDEs. So building tools for C++, it's not easy, but we have plenty of them. And it's just a matter of knowing them and using them. If we're talking about the whole picture, the whole ecosystem of things that you might need from a good code editor or an IDE, linters, formatters, visual debuggers, if possible, automated refactoring tools, build systems, package managers, CI/CD services, a good code review platform, a good compiler with lots of good diagnostics that we can leverage and use, good profiler that we can easily use and will give us hints on what to attack next. Testing frameworks. It's not just a matter of discipline. A good testing framework really helps and encourages people to write more tests, as opposed to something that's awkward to use. Also, mocking is an important issue for many scenarios. So having a good framework there really makes a difference. Static analyzers, of course, will help us reason about things that are latent in our code and problems that just wait to pop up. And they can do a better job than compiler diagnostics, which need to be fairly fast. So a static analyzer will certainly take more time, and will yield quite a bit of false positives, but at least it will give us lots of starting points. And we have pretty good static analyzers around, from open source free ones like LangTidy to lots of commercial tools that help developers uncover issues in their code. And then we have dynamic analyzers, and we have a bunch of sanitizers from the LLVM project, like address sanitizer, UBSAN, thread sanitizer, memory sanitizer, and so on. They all help us build more robust programs and help us test. And we have fuzzing libraries that help us make sure that we have good coverage in our tests. And yes, it's difficult to build good quality tools for C++, but that doesn't make it impossible. So I've used plenty of great tools. I've tried plenty of crappy ones, but the good news is that this is mostly a myth. There are plenty of good So if we're talking about a debugger or a profiler, let's say, you really need to understand the power of that tool and how you can best leverage it so that you can accomplish the task you want. So I think the takeaway here would be to
interrupt for a moment. You just dropped on my side. I'm not sure if the attendees also had you drop for a moment, but I think we missed about 30 seconds.
Can you hear me now?
Yes, it's back now.
Okay. Okay, so I'll try to maybe rewind a few seconds back. So I was saying it's more important to get to know the tools and be proficient in the tools that you're using to accomplish the task at hand. So do know that the tools you're using inside out, all the quirks or the configs, all the helpful plugins and command lines that you might need. So being proficient in using your tools is more important than complaining about the tool not being perfect. And why not, if you can contribute to the open source or free ones, you can improve them. So you can write your own plugins, you can write your own static analysis checks and so on. Moving on to another myth. Regex, standard Regex is too slow for production use. And this is another one that I keep hearing about. And as a test, Jason and I tried to build a very simple, very trivial matcher. Hypothetically, let's imagine we're trying to parse a config file or something like that, something like a key value pair set, and it actually took us more than 10 minutes or maybe more to come up with the text, with the code that you see on the slide here. So I would say that's disappointing. And it's not like we've never used this API before. It's just that there's so many things that you can get wrong. So you don't need to frequently reach for the documentation and fight the compilation errors. And I would say this is not a very friendly API, and it comes with many gotchas. So among these, I forgot to mention it, this short snippet you see here is actually so slow to compile that Compiler Explorer will time out. So that tells you something. And it doesn't time out, for example, to compile huge libraries like range libraries and things heavily using concepts. So, but it times out on that regex. It is a difficult to use API, and it's because it was designed to be very general purpose and accommodating to lots of kinds of grammars. And in my opinion, it was an over-engineered thing. And the results, although the goals were well-intentioned, the result is disappointing. And it wasn't a rushed thing. So this was a carefully crafted thing, and people seem to not being able to use it. It's very slow to compile, and it's very slow at runtime. And it comes with various performance gotchas, such as the constructor for the regex object. People need to be very careful when constructing these, because if they end up in hot paths, it could tank your performance for sure. Even the C match type when constructed might be expensive. So people need to be very careful in hoisting these out of their hot paths if they use it. So highly encouraged to use CTRE library instead, compile time regular expressions library. It's very fast to compile. In my opinion, it has a much cleaner API, and it does support string view, which was not retrofitted to standard regex yet. And it builds regular expressions automata at compile time. That's where the runtime performance comes from. I've linked here to the repo. People keep asking when is this going to come into the standard. I don't think it's going to ever come into the standard, and that's a good thing. But it's a fairly easy library to adopt. So I do encourage you to, next time you need something like that, give it a try. Check out the documentation. Check out Hanna Dusikova's presentation about CTRE and its evolution, and take it for a spin. It will be well worth it. So yeah, this one is confirmed. Standard regex is too slow for production use, so I wouldn't touch that with a 10-foot pole. And I've actually seen people go for manual string manipulation instead of using standard regex, just for these reasons. So moving on to another item near and dear to my heart, standard optional. And things that I've heard, like standard optional inhibits optimization and complicates APIs. Well, let's see. There are two things here, but I usually hear them conflated together. If we take a fairly trivial example here, where we generate a value, an optional value, and we try to get the length of this payload, we're using a string as a payload. Fairly trivial example, and it's fairly trivial to analyze as well in terms of compiler output and see what we get there. And if we look at the get size function, although we invoke get value from inside that, we can see the compiler sees right through that, and we don't get any call to get value inside get size there, and we see the computed value directly there, deposited at compile time. So clearly, compilers see right through this this boilerplate, and everything gets inlined and optimized away. You can even decipher things here if you're curious about magic constants that the compiler likes to spit out, things that we don't recognize written by ourselves. You can easily deconstruct this and see this is hell, not just hell, but hello. Things are split for reasons. But you can easily see the compiler was very smart here and was able to pre-compute everything we've written at compile time. So really, this usage of optional, it was not an optimization barrier. As STL itself, most of the constructs we're using, being template, are inlined, and compilers can see through all the magic and the abstraction we write, and we end up with fairly efficient code most of the time. So if we get a longer string, then we no longer have a small string optimization. So we are going to incur heap allocation, of course. But again, even with this heap allocation, the compiler still sees through it and inlines the function, and can, in this situation where the thing we're actually working with is known at compile time, can actually pre-compute its value. So not a real stress for the compiler. No worries in using it a lot. So I would say it generally doesn't inhibit optimization, so it's fairly transparent to the optimizer. However, there are situations that people need to be aware of. For example, if we hoist that string literal out of directly returning it, and we hoist it into a string variable there, And if we're diffing this with the previous example that we have, by the way, I'm not sure if anyone if everyone is familiar with the diff view from Compiler Explorer. You can actually have different outputs and compare maybe different code generations, or maybe under different flags. You can make it show you whatever difference you're trying to examine and have it side by side. So the important bit is here is that we have lots more instructions generated. So we just hoisted the string literal into a new variable, and suddenly we have about 40% more instructions on this trivial case. And what happens there is that we end up copy constructing a string, and this is a fairly easy thing to fall into. And the reason here is that the function getValue returns an optional string, and we're returning a string from this function. And this happens implicitly and can be a performance gotcha that people can run into. So building optionals by copy constructing their built-in built-in type, is something that can be a performance pitfall in some situations. So that's why I say it's plausible maybe for people to notice performance issues when using optionals, is because of this way of constructing optionals. And this is the construction in question here, in that it can construct an object that contains a value as if directly initializing the object of type T of the optional itself with that value. So there are conditions when this constructor participates in overload resolution, but when people usually expect this kind of thing to just work and be able to construct optionals of T out of T's, or out of constructing T's by forwarding to T's constructor, and this helps in creating more streamlined code in some situations, but it comes with performance gotchas sometimes, and it's opaque, and no compiler diagnostics are issued for this kind of stuff, and you just have to be careful and measure. So I would say this is something to look for, but definitely not something to make you stay away from using optional, in my opinion. The other part of the initial myth statement was that standard optional complicates APIs. And this bit I have to maybe contest a bit. The reason some folks say that optional complicates APIs is because they tend to use it wrong. If you try to unwrap that optional too frequently, that's why I call by looking inside the box. The optional is a box, and you kind of have to think of it as a monad. If you try to if you try to test the value, if the value is there, and to extract the value too frequently, then I think you're using it in an anti-pattern kind of way. And yes, in that situation, the code may turn up to be more ugly than without the optional. So you end up with lots of boilerplate in juggling the existence of non-existing or non-existence of the value. So I would say that people should try to avoid to look inside the box too often. And another misuse is that people sometimes try to use optional as error handling. For example, to see if something succeeded, some operation succeeded in generating a value, generating a handle, generating a connection, generating some kind of, yielding some kind of meaningful value to be passed around. So if people are trying to use optional as error handling, I don't think it's a very successful approach, because usually with handling unhappy paths, you're also interested in a reason of why that failed. So I would recommend not using optional for example, opening a file, or committing some kind of transaction, or sending some kind of HTTP request. For scenarios like that might fail for some particular reason, I think more appropriate use would be to use an expected type, or even exceptions if your project allows for such things. So there are implementations of expected out there. I like to recommend the one by SiteBrand. Look for TL expect, so Tartan Llama namespace, and that might help improve the situations where you find yourself using optional unwidely. And in general, when in doubt, I would say to draw inspiration from other APIs. For example, when you're trying to design functions or APIs where you feel the need to use an optional type, try to look for similar APIs in Haskell or in Rust if you're comfortable with one of those. They both have such types, and I think they properly use them. They use them in the right places, and most importantly, you can see examples on how to compose code using such boxes. And I would say it is important to think in terms of high-level functions, high-order functions. Again, try to not peek into the box. Try to use concepts at a higher level of doing transformations on functions. I recommend I recommended in the past, and I still recommend plenty of good presentations like this for C++ developers. For example, Bjorn Faller's high order functions for ordinary developers, if I remember the title correctly. And I did recommend, oops, wrong way. I recommend this fairly intuitive and nice explanation in this blog post on functors, applicatives, and monads. Very good explanation. More or less language agnostic in trying to grasp the way to use these concepts and compose them well. So think about how you want to apply transformations to values that you don't know they're there or not. So this would be a subject for our long talk in itself. But I leave you with some starting points here, and try to dig more on your own and draw inspiration from APIs designed in Rust or Haskell, for if you're familiar with those languages a bit. And I would say that if misused, optional can complicate APIs. If used properly, it can really help build beautiful APIs, in my opinion. Must not forget to mention monadic continuations for standard optional. And yes, we're going to get that in C++23, thanks to SiteBrand again. Until then, there is their implementation is available again in TL namespace on GitHub, on their GitHub. Fairly easy header on the library to use straight away. So if designed properly, my opinion is that optional builds beautiful APIs. Moving on, Standard move moves. I've heard that many times. Not necessarily formulated this way, but people scratching their head this way. Let's start with a very simple example. We have a function taking 2 arguments by constref and tries to do something like maybe concatenate, maybe build some other value out of those inputs. Nothing surprising here. We pass this string by constref into the function, and the function just prints both the duplicated value there. No surprise there. What if we put a move around the first parameter there? Again, people are not surprised with this kind of thing. Again, same output, same result. Nothing to worry here yet. But this is the scenario that freaks people out. And I've seen this in real world code, similar situations. I've seen discussions around these kind of things in code reviews, and it definitely freaks people out, and I think it deserves explanation. It's not a pattern that I would recommend, but it's something that people need to understand before they worry. So what's going on here? Well, the output is just as before, nothing changed. And this is why people are confused, because they expect the greeting to be moved, and the second parameter there, whichever way you count, from the left or from the right, presumably should be affected by the previous move. And this freaks people out. What happens is move actually doesn't move anything. Move is just a cast, an adapter. So you transform the greeting variable into a string ref, and that's it. And this R value reference is automatically convertible to a constref for the input arguments in the echo function. So no real magic happens here. The move cannot occur when we write those magic words. It's definitely the wrong moniker to use for this library facility, but we have to live with it. So move actually can occur when constructing objects or assigning objects. So move doesn't happen when we write those magic words there. We're just saying that we're ready for this opportunity to occur, but no promises on where that happens. So nothing magic happens here. It's just a reference, just a cast. We can see this better if we drop those references there and try to take those arguments by value. So just strings, no const string refs. And in that situation, things change in the output. We're gonna get the string in the first position and an empty string on the second position. And the reason we get an empty string is that all library implementations just empty the string after it moves. So it leaves the string as an empty string, although not required by the standard, but all implementations do that because it's sensible and it's not costly. And we get the first one. So in what happens here is that we get a move construction here, so a new string object, because we now take it by value in the echo function. A new string is move constructed out of the greeting we provide, and when that happens, the argument on the stack for the frame of the echo function, so our first here, takes ownership of the guts of the buffer of our greeting, and then the second argument is left with whatever remained there, which is an empty string, the state after move, basically. But this happens on Clang. If you happen to be on GCC, you're going to see it the other way around. And this is mainly due to the order of evaluation of arguments, left, right, right to left. Definitely not something that you can count on, not even within the same compiler toolchain. So the reason this happens is that we changed from a constref to a string by value. So now we're constructing strings. So definitely standard move does not move. And there's lots more to learn about move in C++, and there's plenty of material, good teaching material out there. Some of it is very scary because there's lots of corner cases and scenarios that even experts argue about. And if Nico Yosutis can write a 200-page book about move, I would say it's a topic worth investigating. So definitely worth understanding more. But moving along, because we cannot make this a 4-hour talk, always pass input arguments by const reference, because we've just seen this function before. And this is an idiom that comes from old C++, and it's still in use today because it's a proven idiom. And let's say we have a widget, and if we want to cover all our bases, we want to have the L-value constructor, L-value value constructor, and an R-value conversion constructor here from a string, let's say. And this way we can cover all bases or manners in which a widget might be constructed. But if we have more than one argument required in order to construct such a widget, then it quickly becomes a combinatorial problem. So just for 2 arguments, we end up with 4 combinations possible if we want to match every possible way of drawing in values into this constructor, either from temporaries or from L values. So it quickly gets out of hand. It's unreasonable that someone would want to write such things. So in a new pattern emerged when we have situations like when we want to take ownership. This pattern is called a sync pattern. First time I heard about it was from Sean Parent a few years back, and I've been using it ever since. So the simplest way to handle this, and now a common accepted pattern, is to pass these arguments by value. Mind you, we're still using C++ here, don't panic. So we're passing by value, something that our forefathers never allowed for. And we're moving in those values, we're syncing those values into the data members of our widget. And same thing applies for setters, for example. Again, same pattern, we're taking in a new value, we're sucking up a new value, and we're syncing it into our data member. So we can move it in, so to speak. And if we try to analyze a few quick scenarios there, let's say we pass in a string literal for this setter, and we move it in. What happens is we create a string with a literal value, because we have to create the string here. And then we do a move assignment into the name data variable. So 2 operations. If we hoist the content into a string variable, name there, and then we pass name to this setter, then first we have to create the string literal again for the name variable that we hoisted. Then we make a copy of the string, because that's how our signature looks. And then we have to make a move assignment into the data member. If we now decide to move it, So this variable is no longer needed in the frame of the caller. Then we decide to move it into the setter. Then we have 3 operations: create the string with a literal value, move construct the string, and the move assignment into the data member, which happens inside the setter. So 3 operations again. Yes, in scenarios like this one, you can save on the number of operations required. So if we were to use the old style setter pattern, and we use an overload set, and we take the constref setter and we have the r-value setter, which each one does the appropriate thing. In this case, in this particular case, it will fall on the constref overload, and then we just make a copy of the string and save a move. So yeah, technically this would be more efficient with one less move operation than the sync pattern previously shown. So in some situations, the concrete overloads usage might be more efficient, but I think in most situations this wouldn't be an issue. So maybe for expensive for types where move is expensive, and definitely not feasible if we have multiple arguments. So for multiple arguments, you either have to redesign your API to have single arguments, or consider the sync pattern. So for constructors, for example. So I would say this is also busted. The sync pattern, which is gaining traction, and more and more people are aware and using it, and not freak out in code reviews when they see things passed by value. There's even a clanked ID modernizer check to perform this transformation at scale. So modernize passed by value is a fairly reliable check. We've run it at scale in our code base when we decided to embrace this pattern. It works very well, and you can try it out on your code base as well. So do give this pattern a shot. Moving on, myth 37: make all data members private. Really? Typically, this is seen as good practice. Private stuff, all the goodness and good teaching enforces encapsulation. The object is in control of its internal states and all that good thing. Not all types have invariants to enforce, on the other hand. So if you have, document your invariants. But we have to be aware that not all types have invariants to enforce, and even when they do, they don't have invariants over all their parts. So maybe consider factoring out those classes or those structures to properly group related things in concepts that, not C++ concepts, but real world concepts that translate into invariants and contracts around those grouped items. So you have to be very careful when considering and designing your data, your member functions and your APIs, to consider the narrow contracts that you expect from your callers and what you're trying to protect against. So I think more energy should be spent on properly thinking about the contracts and the invariants necessary or not on our data types than spending that time on getters and setters and unnecessary boilerplate. And talking about complexity, too many people code out of reflex or plan too much for the future and implement all the functions they might need or their colleagues might need in the future. Not a fan of this approach. I'm not saying I want to live in the present, but don't implement everything that you might need, because that just adds complexity. Try to write simpler classes that you can reason about the invariants you want to preserve, if there are any. So in many situations, even consider if you need a constructor or not, because given the brace initialization that we have in recent C++ versions, it's highly convenient in some situations to not have constructors at all. So, and when defining constructors, you might actually hurt performance if you're not defining them well. Think about no except stuff. So consider if you really need constructors for your structures. And yes, I alluded to this earlier. Think about refactoring. If you have something that is too unwieldy to handle or to wrap your head around, or things that need to be protected by some kind of function or magic that needs to happen before setting some internal state, think about refactoring and see this as a refactoring opportunity to simplify the logic, simplify the measures and protections that you need to put in place. Sometimes structs just want to be structs. So I very much enjoyed Kate's presentation yesterday, I think yesterday or the day before, I think yesterday, on abstraction patterns, and she touched on these very topics on structs and invariants, and not all classes and structs need member functions. So I highly encourage you to see the presentation when the video will be published, if you haven't seen it live. So sometimes structs just want to be structs. So I think it's plausible to want to make all your data members private, but there are many scenarios where this is unnecessary complexity. So while we're on the subject of structs, I wouldn't be comfortable with without recommending this presentation by Mike Acton, Data-Oriented Design in C++. I know it's an unpopular opinion in our community, but I still think Mike's keynote at CppCon 2014 is one of the best keynotes, CppCon keynotes I ever seen. And it's all about data transformations. It's about designing your data, about a smart data layout, and arranging your data so that it's best fitted for the transformations you're trying to accomplish on that data. So memory access patterns and smart data layout makes all the difference when you care about performance. Yes, might produce code that's not always that pleasant to look at, or not always as easily as composable, but sometimes composability and the aesthetic factor is not the staple of what you need, the staple of performance code that you might need. So if you're not familiar with the presentation, I highly recommend that you watch it. And it has started a trend and influenced many people. Another presentation that I've seen and I really enjoyed was Andrew Kelly's presentation on applying data-oriented design, a case study on the Zig compiler itself and the improvements that he's been able to achieve leveraging these kinds of approaches and thinking in a data-oriented way, and embracing Mike Acton's way of constructing software. And it's a very interesting case study, and I highly recommend this presentation. I've put here the link. Andrew even sported the now famous Hawaiian shirt that Mike Acton wear at CppCon. So it definitely started a trend. I've seen many follow-up discussions picking up where Mike left off, and exploring more patterns around building structures and accessing structures and constructing transformations that are appropriate for the particular data layout that we choose. All right, moving on, myth 40, iterators must go. Let me try to do a Romanian accent now. What's up with that? Destroy. Did I do it? No. So I finally found the recording of this. By now famous presentation by Andrei Alexandrescu from BoostCon 2009, so a while back. And people keep hearing about it and referencing it, and somehow the recording eluded the internet public record. I finally found a recording of it. If people are curious and want to see the actual thing. So because it started the movement, it started the thing. So it was a highly influential talk for most of the C++ community. It's a very good presentation, and I highly encourage you to see it. The fallout from that presentation was significant. And even Alexander Stepanov was highly irritated by this trend and the people trying to figure out the ideas and distill the ideas and run with Andrei on this path, on this journey to ranges. Alexandrescu is on a crusade to eliminate iterators. Stepanov frustratingly said during programming conversations lectures at A9. So definitely you need to understand the context. You need to look into the whole ecosystem. You need to look at what other programming communities are doing, other programming languages, look at what iterators really are and the problems they're trying to solve, and really understand the design principles behind STL before you make judgments. Don't jump on a bandwagon just because it's trendy. So I highly recommend you watch that presentation a while back by Andrei. And I would say someone did properly destroy, but it took nearly 12 years to do so. And the best thing I've seen to date treating on the subject and picking up where Andrei left off is Barry Revzin in his talk in his keynote on iterators and ranges. And I highly recommend this presentation in various forms. I think this is the most recent one from CPPP conference. A very good treatise on shortcomings and advantages of iterators and ranges, because ranges are not this magical thing that solves all our problems. They have problems. And the reason I enjoyed it so much is that Barry presents very nice, easy to digest examples, and tries to do a comparative study between C++, D language, where all the ideas that Andrei started popularizing over 10 years ago come from. So a comparative study with C++, D, Rust, Java, C#, and others. So a very comprehensive treaty of the way to use algorithms and advantages and disadvantages of ranges with regards to transformation we need to do. And I think if you combine the now famous Iterators Must Go presentation with Barry's newest analysis here, you'll have a clear understanding of advantages and disadvantages of both approaches. And maybe you'll even understand more about other programming languages and their design goals. So I put this one in the plausible category. And towards the end, I would say that the core myth for our community is that new C++ is the enemy of the old. And I just heard this one, and I really enjoyed this quote from Pablo Halpern at this conference. Before we had feature, we were nonetheless able to program in C++. So I think this speaks a lot to the way we usually try to approach changes that come our way, and the reluctance we sometimes have in trying to understand new ways of thinking, or and on the other hand, the way we dismiss old things just because new shiny toys emerge. So I would say, yes, most of the time, new C++ is the enemy of the old in a psychological kind of way, not necessarily on technical. So we need to be more aware of how we learn things and how we gain experience using new things. I'd like to recommend this presentation as well, Some Programming Myths Revisited, by Patrice Ciura from CppCon. It's a more general setting. It's not necessarily C++ specific, although it's heavily based in examples in C++. Patrice analyzes some controversial things that generally programmers stay away from. Some dogmatic things, I would say. And as always, Patrice is an excellent educator and teacher, and it's always a pleasure to follow his presentations. So I do recommend this one when you have the time. I will close by, again, reiterating that I plan to make this a series of presentations, and not just by me. I do invite other speakers to join in this C++ myth busting series, and try to together build a better pool of ideas, and maybe dismantle some of the formed myths, or the old ones and new ones, and most importantly, encourage discussion around these topics. From future episodes, a few things I have planned. I have more, but some things that I picked for the next installments. I'm open to suggestions, of course, and featuring even guest appearances by newcomers to the programming ecosystems, like Rust, borrowing troubles and interop issues with C++ and Rust, memory safety issues in Chromium, lifetime annotations for C++ in Clang, and in general, the idea of trying to retrofit sort of a lifetime thing, like sort of a borrow checker into C++. Lots of teams explored these ideas and published very good research. I do recommend that people read about the memory safety statement in Chromium. The team published a very nice article on the difficulties of memory safety in such a large project with such a large attack surface area, and various approaches that they considered, from very specialized garbage collector to fat pointers and other means of tracking object lifetimes. So very interesting articles. I do encourage you to read up more on that. Question from Heinrich. Do you think lifetime annotations or a borrow checker could be introduced into C++ on a realistic time scale? I see efforts in that direction. I mentioned some of them earlier. most recent attempt I've seen is lifetime annotations for C++. It's an RFC in Clang. There are efforts in this direction. Problems I see with this is that they tend to be highly toolset specific. So these kinds of experiments usually come from the LLVM community, and they although they make tremendous efforts to build something that is usable and easy to adopt, I don't see any industry consensus in either direction. So I'm not very optimistic that we're going to see something real soon. I don't know. Maybe before I retire, I'm hoping to see something. So that doesn't mean we cannot build more robust software, so we can leverage tooling. I'm more optimistic on using annotations and leveraging tooling to detect such issues rather than having things in the language per se. I'm not very optimistic that we're going to get anything in the language without breakage or if we don't want to allow for breaking existing code, then we're not going to have any guarantees on those things. It's like all or nothing. We either have strong guarantees that everything that interconnects, like the barrel checker, guarantees up to unsafe blocks, guarantees that everything is properly checked at compile time. And if we cannot enforce such guarantees due to breaking existing code and the way C++ works, then there's little value to be sold to programmers in terms of being worth it. So the fact that other languages have success with these kinds of approaches is that they embraced it as a whole. So I'm more optimistic on the tooling side than on the language and compiler side. Maybe with markups, maybe with annotations for tooling. Custom attributes, some things like that. There is a very old myth that exception handling is slow in C++. Is it really? Depends who you ask. As some projects do not touch exceptions at all, if you ask people in those niches if exception handling is slow, they would give you a very quick answer. And yes, for them it really, really matters. Definitely it's not acceptable. But I would say for most of the things that we build in industry, I would say that exceptions are not the costly path, are not the costly thing. So most projects, I think, would afford using exceptions. And modern implementations of exceptions are better than they used to be. And generally on the happy path, you don't pay as much of a cost for using exceptions. Things are in terms of ecosystem and targets, things are looking much better on Windows for exceptions. Exception handling on Windows, especially on 64-bit, are way more performant than on other platforms because they were optimized to be so. The operating system was optimized in this regard, and we have a better implementation there. But it really depends on your project. So it's one of those things where it depends is the answer. So in my project, I've used and we've been using exceptions successfully and efficiently. and we even leverage all kinds of interesting things out of exceptions in building better crash reports and stack traces and everything. So we leverage the exception machinery we have at hand, but I wouldn't generalize what we do. So it very much depends on your constraints. So exceptions generally tend to be really bad when you're on the unhappy path, when unwinding happens. And people also need to remember that you also get a little bit of code bloat for exceptions. Functions gain specific things in their prologue and epilogue, and there is significant impact for code generation as well. So it really depends who you ask, but I would say for most of the projects, the exceptions are not the part that slows them down. Okay, I think we're almost out of time. If you do have follow-up questions or comments, do add me in the Discord so that you get my attention, and we'll continue there with any topics that you might have interest of. So, thank you.